I welcome you all for this session on a new topic, hashing. Okay, so we'll see today what is the meaning of hashing. The efficient search techniques are those that minimize the number of comparisons. Okay, we have learned many more searching techniques actually. You can say we discussed about linear search, then binary search. We also discussed about tree searching, in tree how to search. Then one more type of search, I suppose, based on trees, we actually had discussed earlier. So today we'll try to find out is there any possibility to get some searching technique which will be highly efficient, means immediately it should be able to give us some kind of information about where that our data has been placed. Okay, so the efficient search techniques, it is always based on the number of comparisons. If the number of comparisons are minimum, then obviously the searching technique works faster. Optimally, we would like to have a table organization and search technique where there are no unnecessary comparisons. So what is our aim is basically to minimize the number of comparisons. Okay, so if we are successful in minimizing the number of comparisons, then we are able to reach to an efficient way of searching. The most efficient way to organize such a table is an array. You know, array always gives you random access. Random means directly you can jump to a specific location. In linked list or any other thing, that kind of access is not available. In array, yes, you are having random access, means directly you can specify some position. So if I specify position 30, I can directly go to the position 30, which is not the case in case of linked list or some other data structures. Those are termed as sequential data structures. Okay, they only allow us sequential search, whereas array allows us sequential as well as random access. This is accessing a particular position randomly is termed as random access. Okay, so each record is stored at a specific offset from the base address of the table. A table, suppose you treat array as a table. Table doesn't mean the furniture which we are using. Table means some sort of, you can say, pockets. It is having some sort of pockets where you can keep some information. Okay, that kind of thing. Some drawers. That is what we are talking about. Okay, so each record is stored at a specific offset from the base address of the table. Yeah. You know that every array is having some starting address, and offset means how far the information is stored inside that particular array. Starting address is known as the base address, and how far it is stored, that is known as the offset. So each record is stored at a specific offset from the base address of the table. If the record keys are integers, the keys themselves can serve as the indices of the array. You know this thing. In array, we keep on doing this kind of technique. Now, we come towards hashing. What is actually hashing? We will see. A key, we will be using one hashing function or hash function. Okay. Now, what actually this does, that hash function? If you submit the key to the hash function, suppose this is the hash function. If you submit the key to the hash function, then it will generate some position. It will generate some position, and it means that the key will be stored, not only the key, but the corresponding record will be stored at this particular position. Key means what? Suppose your roll number can act as the key. And if I feed the roll number, then I may get where can I find this particular student's information inside the table, inside the array. So this is the way. If this is employee information, if I give the key will be the employee number, this will be integer. If I feed the key to the hashing function, it is able to generate the position. Now, what is the way to generate the position? That we'll learn a bit later. So a key that transforms a key K into table index is called a hash function. Table index means the position of the key inside the table, inside the array. So if you submit the key to the hashing function, it will be giving you the position inside the table or inside the array. If h is a hash function and k is the key, then hk, this is the function, is called as hash of key. Hash of key. Okay, so wherever it is mapping onto, whichever position it is mapping onto, that is the hash of the key. So this whatever position it generates. Hashing function maps some input value to some output value. Mapping is random in nature and no restriction on input. So we have to take care that the mapping should be random in nature. It should not happen that after the first position is filled up, the second position is filled up, then the third position is filled up. It should be random in number. How to random in nature? What do you mean by random in nature? There should be basically equal probability of placing the incoming values onto different outputs. Outputs means the positions. Our output of the hashing function is nothing but the position. So the given key should be mapped onto any of the key value, and selecting any of the key value should be having the equal probability. So we'll see that particular property. This is termed as uniform distribution property. It takes values from input set and should be equal probability of mapping for each value in the output set. So in the whatever is the output set, in that it should be mapped uniformly. Two things, randomly and uniformly. See, here we said mapping should be random in nature. Let any type of input come, no restriction on input, but then it should get converted onto a proper position. So the other property the hash tables should have, it is better that the hash table should have those properties. Uniform distribution property. Any position in the hash table should be, there should be equal chance of selecting the position, any position. Okay. That should be the way we should write the hashing function. Okay. What are the parameters for the hashing or hash table generation? Now, first criteria is design of hashing function. Design of hashing function should be following those two properties. It should be random in nature and uniform distribution property. Should not happen that many of the keys are getting hashed onto a particular value all the time. That should not be the case. Equal chance of distribution. Number of buckets. I'll explain you what is the number of, with the diagram I can show you. Bucket size, number of buckets, and the other criteria is bucket size. If I draw a single array of say 20 locations, then it becomes bucket size 1. Everywhere I'll be storing one record. In each position I'll be storing one record, and there are such 20 locations. So this what is bucket size? can you store more number of records into one position, into one bucket? If that is the case, then what happens? Firstly, I'll show you what is the meaning of the bucket. See, this is hash table with 11 slots and 2 buckets. Why 2 buckets? Because vertically there are 2 positions. So this is key 0. Sorry, this is position 0. At position 0, I can store one record, one complete record, not only the key. Try to understand. If I want to store the student record, then student roll number, name, different subjects he had selected, all those things will become one record. I think you are learning the databases, so you know what is the meaning of one complete record. So one record will be stored at this position. Another record will be stored at this position. So at 0, we are having 2 buckets. So if there are 2 keys which are mapping onto position 0, I can store one key over here, I can store other key over here. Okay. Same thing, if there are 2 keys mapping onto position 3, then I can store one key here, one more key over here. Likewise, how many such drawers or how many such slots I am having? I am having, suppose, 11 slots. So 11 slots and 2 buckets. So I think it should be clear. This is nothing but an array, okay, which is having 2 side-by-side locations where I can store records. Okay. Now, if this single thing also is acting as an array, and this is yet another array, and so it becomes a 2D array. Okay. So 2 buckets means it's a 2D array kind of thing. Now there are 11 slots. I can increase the number of slots. I can make it 1000 also. So no problem. It all depends. Here it is difficult to draw the table for 1000 locations. So I am drawing only for 11 slots. Okay, I hope it is clear. So this is acting as the bucket. This is one bucket and this is second bucket. Okay. So design, what are the parameters for the hashing thing? Hash table maintenance. Design of hashing function. It should, we learned that it should be random and uniform distribution property. They should generate, the function should generate the positions randomly, and the distribution of the keys should be uniform in nature. Should not lie all the keys at the same position. Number of buckets. I just showed you the number of buckets. The third thing is the bucket size. Bucket contains how many elements? How many elements? Now suppose I want to increase this bucket size. So what can happen? Instead of storing single record over here at this position, I can make it storing 5 records, storing 10 records. Okay. So what happens if I maintain it for storing 10 records? At every position, I can store 10 records here and 10 more records over here. So that will be with keys, position 0, I am having 20 records, actually 10 in this bucket and 10 in this bucket. Now what happens if I go on incrementing the number of records which are lying inside one bucket? Then how to search? Our main objective behind generating hash table is that we want faster access. We want faster access. We want to reach to the specific record quickly as possible. So if you maintain 10 records in this particular position, what happens? Once, suppose you could reach to the position 0 or any position, suppose position 5. But here there are, at position 5 also there are 10 records here in first bucket and 10 in the second bucket. If I do it like that, then inside the bucket I need to search sequentially. So that will slow down our speed. That will slow down our speed. Inside the bucket, the search will become sequential. So we don't want that way. Or depending upon users' requirement, we can adjust how many slots should be there, and how many buckets we can maintain. Okay. So the bucket size indicates how many records you can, how many tuples, how many records you can store inside one bucket. Overflow handling mechanism. What is overflow? That the answer is hidden in this particular situation. Firstly, we should learn collision. What is collision? If two or more keys hash onto the same value, then collision takes place. It can happen that two keys are generating the same position. If it is so, because what we discussed that we should only feed the key to the hashing function and it should generate the position. It should not be very complex mechanism to generate the position. It should be quite simple mechanism. Then it will be, there can be higher chances that many more times the keys are mapping onto the same position. If it is so, this is termed as a collision. If the collision occurs, and if the bucket is full, then where will you store such record? I'll explain with the diagram again. Suppose for position 5, let us think about only single record here in the first bucket and single record in the second bucket. Now, there are two buckets, so I can store two records at the same position 5. Okay. Now, see here, third key comes, which is again mapped, which is again hashing onto the same position. So what should I do? This becomes overflow. This becomes overflow. Whenever the collisions are there, it may result into the overflow. So where should I store this incoming key, third key? First key I'll store here, second key I'll store here. Where should I store the third key? That is what is termed as the overflow. So overflow handling mechanism. Okay. So all those things are very important. Design of the hashing function, how many number of buckets you are maintaining, how much is the bucket size inside one bucket, how many records, how many tuples you are storing, and if overflow happens, if overflow takes place, what is the mechanism? What is the mechanism? So today let us discuss about some simple thing and then we'll go over towards the overflow and the other things. I think this diagram is clear to you. If number of buckets are increased, keeping other things the same, collisions may decrease. Means instead of 2 buckets, if I use 100 buckets, this will reduce the collisions. Reduce the collisions means now I am having, with this, for the same key value, I am having 100 slots, 100 buckets. So I can store 100 at 100 different things. I can store the keys. Okay, inside the same position, I am having 100 different locations where I can store the incoming keys. Okay, so that is the way I can resolve the collision, but this may decrease, the collisions may decrease, but we have poor utilization of space. Poor utilization of space. Why? Because we have tremendously increased the size. Then many times the remaining buckets may be empty. Only a few buckets are occupied. So this will result in poor utilization of space. Okay, unnecessarily we are declaring too high memory. So if bucket size is too small, collisions will increase. But if bucket size is large, memory requirement to read the full bucket will be large, and also searching will become serial for that big bucket, sequential search, one after another. So increasing bucket size or number of buckets is not very good solution. Okay, to some extent, yes, you can have 2 buckets, 3 buckets, fine, but you should not go to a higher limit, because that will actually hamper our very purpose of hash table. What we want is quick search, and this may reduce, because of the sequential searching, it may reduce the uh, probability of getting the record very fast. Okay, when range of input values is not known, generally best suited method is division remainder method for hashing function. Till now we have not discussed which type of hashing functions we should use. There are many more types of hashing function. Today I'll explain you one simple technique which is termed as division remainder technique. Okay, so the speciality of this is the range of input values can be anything. Even if it is not known, still the division remainder technique works well. Okay, remember, for this technique we should have the key in the integer form. This is what is the requirement. If the key is not integer, it will increase our trouble. Division remainder method. N equals to maximum number of buckets, say 10. Sorry, it should be maximum number of slots. Okay, so actually a maximum number of slots, here I am having 10 such slots. Okay, now maximum number of slots is 10. What the division remainder technique is saying, suppose the key value is 65. So what we should do? Key mod n, the number, the maximum number. Okay, so maximum number is 10. You can see array of 10. I am having array of 10. And if the incoming key value is 65, so a simple technique I use is 65 mod 10. 10 is maximum thing. Okay, so 65 mod 10 will result into 5. Remainder, mod means the remainder. So 65 mod 10 results into 5. So this is division remainder technique. Now it tells us that hash function is division remainder hash function. If I feed the key value 65 to it, it is generating the position as 5. It means that inside our array, inside our hash table, we should store at 5th position the value 65, or the corresponding complete record, the complete tuple should be stored at position 5. Okay, so position 5, 65 will be stored. I hope this is simple thing. You must have understood what is division remainder technique. The key mod n, maximum number, what is the size of the array? Okay, so how many how many positions are available? 0, 1, 2, like that. I'm having 10. So if you divide it by the key value by 10, mod, take remainder, the remainder will be 5. So the key value goes at the 5th position. This is termed as the division remainder technique. Okay, now let us check how we store the further keys. Next key is 123. So 123 mod 10 will give me 3. The remainder is 3. So it should go at the 3rd position, the complete record. This key, try to understand, key means suppose someone is having roll number 123, then that student's name, his marks, his subjects, whatever other details also are to be stored. So key indicates the roll number in a student record. For employee record, this is indicating the employee number, and maybe the employee name, his basic salary, and other details I need to, his DA, HRA, the taxes, other things he is paying. So all those things will go as the record. Similarly, if I want to maintain the book record in the library, the book records are to be stored. Now, this 123 will be the book number. Okay. You might have learned in the library, there is one thing which is termed as accession number. So they use the accession number as the key. So here, that accession number is nothing but the key. So suppose 123 is the accession number, then it will be going at the third location. Now, what all things I should store in this? If it is a book, the book number or the accession number, then the book name, author or the number of authors, then the publisher, okay, so on and so forth. So other details of the book I'll store, its price, number of pages, all those things I can store over here. So that becomes one record. Now, this, I hope you have understood how the key value is fed to the hashing function. The hashing function is using the division remainder technique and will be generating the position 3. So 123 key will go at the position 3. Now comes key 328. So where do we store 328? 328 mod 10. The remainder is 8. It means this value should go at 328. Okay. So that is how we store the tuple at 328. Next comes 547. The remainder 547 mod 10. It's 7. So what I do? At 7th position, I'll be storing the key 547. Okay. So at 7th position, I'll be storing the key 547. Now, you must have understood how the keys are coming. The keys are coming in any order and you can store it at the appropriate position. Now comes 76. So where should 76 go? It's 76 mod 10, it's 6, so it should go at the 6th position. Okay. Now comes 135. 135 mod 10 is 5, and already at 5 there is one record stored. This is 65, and that is how this is termed as a collision. Two keys are hashed at the same position. It is termed as a collision. Okay. Okay, so this is two keys hashed at the same position. And that's why 135 will result into a collision. Now, where should I store if there is a collision? If two keys collide, then where should I store the key? There are very simple techniques that I should store it in the next immediate empty slot. Okay, so I can store it over here, but it is occupied, so I can store it over here. If that is also occupied, I will check this. If that is also occupied, I will check that. If that is also occupied, I should go here. So it all depends where you want to store. Now, there are some techniques for this collision handling, and how to handle the collision. Based on that, the collided keys are stored at different locations, and different techniques are used. So today we stop over here, and now tomorrow's session we will learn about the where the collided keys are stored. So there are different techniques like chaining or something like that. So we'll learn all those things in our next session. Thank you.